Kappa Architecture, a stream-first approach to data processing. It is a unified architecture that processes all data as streams, eliminating the complexity of separate batch and stream processing systems. Let's understand the difference between Lambda and Kappa architectures. Lambda architecture uses separate batch and stream processing layers, which adds complexity in maintaining two different systems. Kappa architecture, on the other hand, uses a single stream processing layer that handles all data as continuous streams, simplifying the overall architecture. There are two core principles of Kappa architecture. First, everything is a stream, meaning all data flows through the system as continuous streams. Second, single processing paradigm, meaning unified stream processing eliminates complexity. Kappa architecture consists of three main components. The first component is data sources such as events, logs, sensors, and applications. The second is stream processing, which involves real-time computation and transformation of the data. The third component is the serving layer, which provides a query interface and data storage. Stream processing involves a continuous pipeline with filtering, transformation, windowing, and aggregation operations. For example, a stream comes from Kafka stream events. Then we can filter the stream, transform the event, and aggregate based on time window, say 5 minutes. Finally, this process stream can be sent to output topic. There are two key benefits of Kappa architecture. The first is simplified architecture. Single processing paradigm reduces system complexity and maintenance overhead. The second is real-time processing. Low-latency stream processing enables immediate insights and responses. Kappa architecture is ideal for various use cases, including real-time analytics and monitoring dashboards, fraud detection and security alerting systems, and personalization and recommendation engines. To summarize, Kappa architecture adopts a stream-first approach to simplify data architecture, eliminating the complexity of batch stream processing. It is perfect for real-time applications requiring low latency and simplified operations. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.